I'll let them see. We did a practice problem there. It's for the people on video. Okay, so Macy Carlson, you said you thought you had one, or it's so confusing you didn't even have a question.
I have too many questions, I can't decide which one.
Should we give everybody, some other people a chance, and whatever they don't ask that you would like them to,
Yeah,
you can jump in? Okay, somebody else want to help her out? Macy Hogshead,
23.
do you know what that is?
Integral of the square root of 16 minus 4x squared dx.
Oh, yes.
That was a hard one?
The
So,
answer was
well, it may be the answer. Sometimes the answers. Do you want to just jump to the answer and see if we can see it? If that's the issue? Or do you want to see it work from start to finish?
Can we
Okay.
It can't hurt.
That makes it easy. So because we have a square root and a minus sign, then we know that whatever precedes the minus sign is going to be our hypotenuse squared. So that's that a squared 16 is a is 4. That's going to be the hypotenuse. Now, the other two sides, and this is where I inevitably choose the wrong way. One of them is going to be the square root of 4x squared, and the other one is going to be the radical. Okay, so and if I get the wrong one in one place, then I know I just switch it around. So I'm going to guess and say 2x and the radical here. Once in a while. Even a blind squirrel finds a nut once in a while, right? So what we want then is we want to connect the term that just has x in it with the constant. And we want that to be either a sine, a tangent, or a secant. If it ends up being one of the other cofunctions, a cosine, or a cotangent, or a cosecant, that means I chose the wrong place, and I'm just going to switch them and then do it over again. So here, matching these up would be opposite over hypotenuse is going to be a sine, which is what we want. So I lucked into it. So sine of theta is 2x over 4. I guess I could call that x over 2. And I'm going to multiply the 2 to the other side. And I need to solve it for x. And I need to have x because I need dx, because I got to replace everything in here by thetas and d thetas and so on. So that I can then hopefully get an integral that I can do. That kind of makes sense a little bit? Okay, so dx, this is really dx d theta, but I'm going to multiply the d theta to the other side. And so that's going to be 2 cosine theta, and then I'm moving the d theta to the other side. So now I have something to put in for the dx. I need something for the radical. So I'm going back to the triangle, and I want to get the radical paired up with a constant, not the x, because then it's going to make it a mess. So the trig function that connects the radical with the constant is a cosine. So cosine of theta is the radical over the constant. So multiply the 4 over, and here's going to be our substitution for the radical. We're going to say that square root is 4 cosine theta. That's why I wanted a constant. I didn't want to throw in another variable there. That's just going to make, then I have to get rid of that in terms of theta. It becomes a never-ending spiral. Okay, so now we can say this integral, the radical is going to get replaced by 4 cosine theta. The dx gets replaced by a 2 cosine theta d theta. Okay, so far? So the 4 and the 2 multiplied come outside as 8. And now we've got our cosine squared theta d theta. Good thing we've been working on those integrals involving powers of sines and cosines. And you're free to use that sheet that says 7.3 on the top and kind of coaches you through how to do this. You're going to be able to use that on the test and on the final. Okay, so I think we have to do a power reducing formula here. And that's on your sheet. And it says that cosine squared theta can be replaced by plus cosine 2 theta all over 2 d theta. Is that okay? So, is that okay?
I keep forgetting about that.
Oh, don't forget. The 1/2 comes outside, makes that a 4. And now we have 1 plus cosine 2 theta d theta. Oh, I think I see where the issue comes here.
Yep.
So we're going to integrate each of these. So integral of 1 with respect to theta is just theta. Times the 4 is going to be 4 theta. We can maybe do a u substitution in our head. U is 2 theta. So the integral of this is going to be a sine 2 theta with a 1/2 in front. The 1/2 will multiply the 4 and be 2 sine 2 theta. Plus c. This is the issue, right? This is why on the very sheet that I gave you with that power reducing formula, right in the very, very second line, it gives you the identity for sine 2 theta. See it? That's why. Because we can't work with 2 theta. But that is 2 sine theta cosine theta. See it?
No.
Rebecca, no. Yeah. Right, very second line. Right under the title. It's sine 2 theta equals 2 sine theta cosine theta.
On which sheet? Oh. Yeah, okay.
You may not have it. So you got yours off Canvas, right? Let me give you a different version because I doctored it up. So if you took it right off Canvas, it doesn't say that. Right,
Yeah, okay.
So it's right there.
Oh,
So
okay.
cool. That was a hard one.
Can I just take a picture of this and give it?
Yeah, oh, yeah, that's fine. You don't want to.
Because I will lose it.
You don't want to keep it for when you take the test.
I suppose I will.
Okay.
Thank you.
Yeah. Somebody else need that? We okay? You finding it? So now we're in business. Because now 4 theta, well, no, sorry. So theta, see, we have back over here, we need to solve this for theta. So we have sine theta equals x over 2. So we're going to have to take the inverse sine or the arc sine, whichever you want to call it. So theta is going to be arc sine of x over 2. Okay? So that's going to be a 4 arc sine of x over 2, plus that's going to be 4. And sine theta is opposite over hypotenuse, which we said was x over 2. Is that okay? And cosine theta is adjacent over hypotenuse. It's going to be a square root of 16 minus 4x squared all over 4. I guess we can clean up a little bit. Guess that 4 will cancel with that 4. And however you want to write that, either this times this over 2 or 1/2 of that times that. It's a matter of personal preference. Does that mention the answer in the back per chance?
It is.
Nice. I like it when we agree. Great.
If it was like sine 4 theta, could that become like 4 sine theta cosine theta, or?
We'd have to do it twice. I have to think about that. So sine 4 theta, actually that wouldn't work because we would make this 2 sine 2 theta cosine 2 theta, right? Because this angle doubled is that angle. Now this we could do again. That would be 2 times 2 sine theta cosine theta, but this has a different identity. And I didn't give you that one because I don't think it ever comes up. But I think it's cosine squared theta minus. There's like 3 different ones for that one. This is the only one I remember. I think it's that. I'm pretty sure it's that. But you'd have to break it down further.
So if we get to that point on the test, we did something.
Then you know you made a mistake. Sometimes I get a kick out of the way you think. Sometimes.
Cool,
Does
thanks.
that work, Grace?
Yeah.
Okay, anything else? Never enough time. So we are going to do today, we've talked about this before. but now we're doing it as a technique for integration. So it's partial fractions, or partial fraction decomposition, it's sometimes called. So if we only allow real numbers, which is the world we live in calculus, so we never deal with imaginaries. So if we end up with a square root of a negative, in our world, that means it doesn't exist. It's not defined. So in the world of real numbers, every polynomial with real coefficients can be factored into linear and irreducible quadratics, irreducible quadratic factors. Linear and irreducible quadratic factors. So, interestingly enough, that means any cubic you want to throw up there can be factored. We may not be able to do it, but it can be. There is a way to do it. So this is a big deal in math. Now, for us, some quadratics are not reducible. So we can't factor that any further with only real numbers. If we were going to allow imaginaries, I don't know if you remember, that would be x plus I, x minus I. So you could factor it in. If you allowed imaginaries, then anything can be factored all the way into linear factors. So any nth degree polynomial could be factored into n linear factors. If we are only going to allow real numbers, which is the world we're living in, then you have to settle for sometimes quadratic that we can't factor any further. Okay, so that's just a fact. So we know we've been through this before, so I think we can jump into it. In AP, you will never be asked to do anything other than a linear factor decomposition. You'll never see any irreducible quadratics on an AP test question. The same cannot be said for an in-class exam. So, yeah. So let's jump right into some quadratic factors. So we're going to integrate 2x to the third minus 4x minus 8 all over x squared minus x times x squared plus 4 dx. Now we should be careful that before we jump into any of these partial fraction decompositions, we should make sure the degree of the numerator is less than the degree of the denominator. If it isn't, then what do we do? You got to long divide first, and then you'll take whatever your remainder is over what you're dividing by, and then you might have to do a partial fraction decomposition. But this, what's the degree of the denominator? 4, right? Because x squared times x squared. There's an x to the fourth, and this is a cubic, so we're okay. So that means we can factor this a little bit more. What about that x squared minus x? But the x squared plus 4 is irreducible. So you remember how we're going to do this? We're going to get what?
A over x
Good.
plus b
Over
over x plus 1.
good. X minus 1,
Oh,
yeah.
plus
And then plus cx plus d over the x squared plus 4.
How did we decide it was a CX plus D?
Well, it's always got to be a 1 degree less than what we have in the denominator. And since we're only going to have either linear factors or quadratics, then the numerator is always going to be just a constant in the case of a linear, but it's going to have to be like an mx plus b in the case of a quadratic.
Got it.
Okay? All right, so we're going to multiply through by that least common denominator, which is going to be the x minus 1, and the x squared plus 4. Remember doing this? Maybe these were the good old days.
That's not how I.
That's not how you would call it. So we're going to get 2x cubed minus 4x minus 8 on the left side, because that'll wipe out that entire denominator in our integral. And we'll get the a. The x will drop out. We'll still have an x minus 1 and an x squared plus 4. Is this all making sense? And then the next one, the x minus 1s will cancel. So we'll get an x and our x squared plus 4. And then the x squared plus 4 will cancel. We'll get our cx plus d, an x, and an x minus 1. Now for the linear factors, it works really slick to just plug in a nice number. The quadratics, then we're going to have to be more creative. But we do have some linear factors. So what would we start with? What's a good choice for x? 0, yeah. So remember, what we're saying is that this is true, this equation is true for all values of x. Therefore, it must be true for, and we can handpick some nice choices. 0 being a good choice. So plugging in 0 means the left side will just be -8. Now, on this a, let's see, 0 minus 1 is -1. 0 squared plus 4 is 4. 4 times -1 times a is going to be -4a, and the others all have just an x in them, so plugging in 0 is going to make them disappear. And so, with a minimum of pain and suffering, we get that we know a is equal to 2. Okay? And what's another nice choice for x? 1. So we get 2 minus 4 is -2, minus 8 is -10 on the left side. Plugging in 1 makes the x minus 1 0, so that wipes out the entire first term. Second term we're going to have to deal with. -1 for x, -1 squared plus 4 is 5. 5 times -1 times b is going to be
Why is it -1?
how about +1? Let me try that again. How about 1 squared is 1 plus 4 is 5 times 1 is still 5b. That look better? I'll do that every now and then to see if you're paying attention. I think it's just you, Karen. So b is going to be -2. And now there's no easy way to go. So, you got a good feeling about any particular number here?
0.
You use 0 already.
No, not 0.
-1 sounds good. I think -1 or 2 probably are our best bet. So we plug in -1. Then on the left side, -1 cubed is -1 times 2 is -2. -4 times -1 is +4. So the -2, the +4 is 2, minus 8 is -6. Does that sound like I did that right? Okay, now we're plugging in -1. So -1 minus 1 is -2. -1 squared is 1 plus 4 is 5. And the a we said was 2. So 2 times -2 times 5 is going to be -20. See, the b we know is -2. The a we said was -1. -1 squared plus 4 is 5. So -2 times -1 times 5 is +10. Okay. And we're plugging in -1. So we get -1 times -2 is 2. -1 is going to be a -c, so that's going to be a -2c plus 2d. -2c plus 2d. Did I do that right? All right, so let's see. The -20 and the 10 make -10. Add that to the other side, we'll make that 4. So we have 4 equals -2c plus 2d. Because we can, let's divide by 2 and call that 2 is -c plus d. Now, this has 2 unknowns, which means we have to go back and get another equation with those same 2 unknowns, so we can use our superior algebra 2 skills to solve this system of 2 equations and 2 unknowns. Maybe a little aspirational thinking there. All right, so we got zero, we use 0, 1, and -1. I got a good feeling about anything else?
2.
Why not? 2. So now we're going to plug into 2 cubed is 8 times 4 is 16. -4 times 2 is -8. Another negative, I think it's all going to be 0, right? Let's see. A is 2. X is 2, so 2 minus 1 is 1. 2 squared is 4, plus 4 is 8. 2 times 1 times 8, I think is 16. Let's see, B we said was -2. A, or X we're choosing to be 2. 2 squared is 4, plus 4 is 8. Looks like maybe 8, 2, and 2 is -32. And now let's see what we got. We got 2C plus D, and then 2 times 2 minus 1 is 2. If we distribute that, I think we get 4C plus 2D. 4C plus 2D. You all in the same place? We can say 16 minus 32 is -16. Add that to the other side. Makes that 16 is 4C plus 2D. So we divide all that by 2 and get 8 is equal to 2C plus D. Okay, so far.
Yes.
So we have a choice now. You can do a substitution, that is you can solve for C or D in one of these and plug that into the other one, or your elimination method is to multiply one or both of these equations by some number, add them together so the variables drop out.
I like elimination.
I do too. I was hoping you would say that. So we multiply the top equation by -1 and add?
Yeah.
Why not? You're just here for the ride anyway, huh? C minus D, does that look right? -2 is equal to C minus D. If we multiply the first equation by -1, we add those two equations together. Kent, your link is timed out. 6, and that looks like 3C because the D's drop out. So it looks like C is 2. You agree? Rebecca? Okay. So once we know C, we can go back anywhere we like. What do you think? You like 1, 2, or 3? 1. So that means we have 2 equals -2 plus D. So I think that's going to make D be 4. Does that sound right? Now, unlike what we did before, now we got to actually do the integral. So now we're saying is this integral. Yeah, I know, this is like where all this work and I still have to do more. So now it becomes the integral of A, which we said was 2 over X, plus the B, we said I'll go minus the integral of 2 over X minus 1. See where I'm getting this from? And then, let's see, we got plus the integral of Cx plus D. C was 2, D is 4. So 2x plus 4 over x squared plus 4 dx. All right. Well, I'm not saying the end is in sight, but we're almost to the place where we can see the end. Okay. First one, pretty straightforward. That integral is going to be what? 2 natural log absolute value of x minus, waiting for it. Nice. Now it gets more complicated. What in the world do we do with this?
We make use of
If we said u, we'd go with u equals x squared plus 4, but the d doesn't pick up both the x and the 4. You were so good at this at one time. You're making it harder than it has to be. You just split it apart?
Oh, yeah, we split it apart.
Good call.
Ours do.
So can we make this the integral of 2x over x squared plus 4 plus the integral of 4 over x squared plus 4? Okay. It's a start. Now, the first integral, what do we do with that? Good, so u is going to be, good, and du is going to be just what we want it to be. And so it's going to be the integral of du over u. And we recognize that as being natural log of, good. And you can put in an absolute value or not. Since this will never be negative, we can flaunt our knowledge of algebra skills and just leave it without the absolute value, or if we don't have much confidence, we can put it in absolute values and just play it safe. How about that next one? It's been a while. It is an inverse trig function indeed. Which inverse trig function might it be? Okay, so to make it an arctangent, what are we going to need to do? Pull that 4 out, and then we'll pull a 4 out of the denominator. That's going to make the denominator be, good, plus 1. You with me there?
Yeah.
Now we need a u substitution. Nice. So if u is x over 2, du is a half. So dx is 2 du. We okay with that? So we got rid of that 4 over 4. We have our dx is now 2 du over u squared plus 1. And that's going to be, so easy to fix, plus 2, we're going to call this an arctangent of the u, which was x over 2, plus c. Is that okay? Just for the record, because this doesn't really matter right now, but there's a time coming where it will matter, is that if we looked at this, how could we condense that?
You could just put it in the same natural log for like the next.
So,
X over X moves.
so you can say 2 natural log of this over that. That's the part that's the most important. And if you wanted, what could you do with that too? Yeah. Easy for you to say. Okay. Is that okay? So the squaring part is okay. This part is going to play a big role down the road, not too far from now. So kind of want to plant that seed down. Okay, so let's do our repeated quadratic factors. So we'll look at the integral of 8x cubed, 8x cubed plus, what did I write there? I think that's 13x all over x squared plus 2 squared dx. So we have an irreducible quadratic to the second power. So remember how we do this? Over, there's more.
Cx plus d over x squared plus 2 squared?
Exactly, very nice. So we need each of the powers represented there. Is that okay? Okay, and so we will multiply by our least common denominator, so that x squared plus 2 squared. Wipes everything out here, so we get 8x cubed plus 13x. Here, one of the x squared plus 2's will cancel. We're going to get ax plus b times x squared plus 2. And both the x squared plus 2's cancel here. We still have a cx plus d, starting to look like the alphabet. Now, we don't have any linear factors here, so we can't, it doesn't really work well to do our strategy of let's plug in nice numbers for x, because there really aren't any very nice numbers. So instead, do you remember what we're going to do? You're going to multiply it all out and then equate coefficients. So we're going to, if we multiply this out, that's going to be ax to the third, and we're going to get,
2ax.
I'm going to get the squared term next. Bx squared, yeah, and then you're going to get a 2ax, and I'm going to put this cx in there with it, and then we're going to get a 2b plus d. So what we're going to do is we'll look at these two terms that have that x in it, and we're going to factor out the x, which will leave us with 2a plus c. So we have a coefficient of x that's 2a plus c. And then all of this stuff is our constant. The 2b plus d has no x in it at all. So then as we look at the left and the right sides, the only way this is going to be really equal is if the coefficients of like terms are equal to each other. So the coefficient of the cube term here must equal the coefficient of the cube term on the right side. Wow, that's great, because that means that we know that a must be 8. Is that okay? And in a similar fashion, we can say the coefficient of the x squared term here, which is 0, must equal the coefficient of the x squared term here. And so we get that b must be 0. The coefficient of the x term, oh, bummer. We're going to have to equal the coefficient of x there, except that we already know what a is. So that means that 13 is going to be 2 times the 8 that we already found out was a plus c. So I guess c must be -3. Oh, that wasn't too bad. And our constant over here, which we don't have a constant, must equal this constant. So 0 is going to be, oh, and b is 0 too. Oh, look at there. Bunch of zeros. That makes life good. Okay, progress is being made. So now our integral, I destroyed some of the evidence up here. So clear some room to work. Can I erase all this? And I'm going to keep my a, b's, and c's. Okay, so now our integral becomes ax plus b, which is 8x, oh, that's nice, plus, let's see, cx plus d, it's going to be -3x over x squared plus 2. Well, that's not too bad. What do you think? Let's see, a good u substitution there. I think we can do it for both of them, right? So u in each of these integrals is going to be our denominator, our x squared plus 2, I guess. Not the entire denominator on the second integral. So the du is going to be 2x dx. So the du will be, or the dx will be du over 2x. So our first integral, 8x over u, and the dx is replaced by du over 2x, which makes that 4 times our integral of 1 over u du, which is going to be 4.
Natural order.
Good. And go right to the u, which is our x squared plus 2. Moving to our other integral, we've got the negative 3x, we're going to call it over u squared, and we'll get a du over 2x from there. Is that okay?
Well, there should be an X in the numerator.
Ah, thank you. Boy, you're on it today, Karen, that's nice. The x's drop out. We can pull out that negative 3/2, maybe write that in a more integral-friendly form. Call that u to the negative 2 du, which will give us u to the negative 1, and then we'll get 3/2, so we have a positive 3/2. So I'm going to come back over here with it, and maybe go plus 3 over 2 x squared plus 2. Also a constant, is that look good? Very nice. Excellent. Okay. So we can sometimes do this, still partial fractions, but it might be a disguised partial fractions. So let's see if you can see how clever we are. See how, let me rephrase that. See how clever you are. And can you make this into a partial fraction decomposition integral? Of course, the answer is yes. Bring on the challenge. Crying for it. Or is it they're just crying? Sometimes it's hard to tell. Can you see that that's a disguised partial fraction decomposition? I think we're ready to come to the board, yes. I'll pause the video here, but don't pause your efforts. Sorry, time to remember, all right?
As you can tell, my brain's not.
Wait, can you mind
No,
me
you
one?
just do it. Well, I mean, I guess I can, but
Minus
it's
E1.
just central, like,
So one,
Okay.
Great.
Wouldn't you have to add the A? Like,
So, we don't want to
Select one is
oh, okay.
So that's
We
going
actually have
to
to press all up there.
Now it is, that was fun. Next time we get a chance, we need to do another problem like that. Maybe not.
So,
Well, yeah, you come up with a random interval. Maybe that's.
I didn't
So we clear on where we're headed here. Test on Friday morning is going to be just on chapter 6. Then I think we got next Friday is the test on chapter 7. Then I think on the Friday after that, we've got the semester 1 final. Then the Friday after that, you'll be on vacation. See if you're paying attention.
That's unfortunate. Well, your other classes have fun on that.